All right, everybody. Okay, let's go ahead and start doing our first solutions video. This is chapter 1, section 1, homework assignment. All right, the first one. A newspaper posted this question on its website. How often do you seek medical information online? Of 1,072 internet users who chose to respond, 38% of them responded with frequently. What term is used to describe this type of survey in which the people surveyed consisted of those who decided to respond? What is wrong with this type of sampling method? Okay, this type is called since they chose themselves, it's a self-selected survey, a self-selected sample. What's wrong with it? Many people may choose not to respond to the survey. Responses may not reflect the opinions of the general population. It's too time-consuming, too inexpensive. What is wrong? Well, many people chose not to. It's only people who have either they have a strong feeling, they're fans of it, or they really hate it. So many people who may choose not to respond to the survey. Number 2, when testing a new treatment, what is the difference between statistical significance and practical significance? Can a treatment have statistical significance but not practical significance? Good question. Let's see. Statistical significance is achieved when the results is very unlikely to occur by chance. That's true. That's by definition. Practical significance is related to whether common sense suggests that the treatment makes enough of a difference to justify its use. It is not possible for a treatment to have statistical significance but not practical significance. Okay, so that's not true. Statistical significance is achieved when the results is very unlikely to occur by chance. Practical significance is related to whether common sense suggests that the treatment makes enough of a difference to justify its use. It is possible for a treatment to have statistical but not practical. It is possible, yes. So far that's the best one. Statistical significance is related to whether common sense suggests, no, that's not, that one's off to begin with. So again, statistical significance is a very unlikely chance of occurrence. So C and D can't be it. And because this A says it's not possible, it can't be it. So the answer has to be B. Number 3. Determine whether the source given below has the potential to create a bias in the statistical study. Washington University obtained word counts from the most popular novels of the past 5 years. There does not appear to be any potential to create a bias. The organization would not gain from putting the spin on the results. True, there has to be a reason to put a bias on there, so that was surprisingly pretty good. There does not appear to be a potential for a create bias. The organization is reputable and has many professionals and credible members. That's irrelevant, so forget that one. There does appear to be a potential bias. There is an incentive to make the results statistical from word count. No, it's not statistically significant because it has nothing to do with not happening by itself. There does appear to be a potential for create bias. There is an incentive to produce results that are in line with the organization's creed. And again, you can't say anything about Washington University. We don't know about that. So the only one that makes sense is this one. There does not be any potential to create a bias. The organization would not gain from anything. So there's no incentive to get to lie, cheat, or steal there. An article noted that chocolate is rich in flavonoids. The article reports that regular consumption of food rich in flavonoids may reduce the risk of coronary heart disease. The study received funding from the candy company and a chocolate manufacturers association. Identify and explain at least one source of bias in the study described. Then suggests how the bias might have been avoided. The question used in the study might have caused the respondents to give inaccurate or dishonest responses. The question wording should be changed to be more neutral. There is no question. It simply says regular consumption of food. So that one's not right. Since the sample is self-selected, is it self-selected? Receive funding. Nope, it's not self-selected, so that's wrong. Because it received funding from candy companies for that, so there is no self-selected. The data did not seem to support the claims being made by the article. The article's authors should consult the experts and make. They did. They have a candy company and chocolate company, so that was not right. So since those are, this one's got to be right. I hope it's right. The researchers may have been more inclined to promote favorable results because funding was provided by the party with a definite interest. The bias could have been avoided if the researchers were not paid by the, yes, that's it. And unfortunately, that's what always happens, is the company who has most to gain will hire some researchers to do a study that will always go in their favor. A magazine which does not accept free products or advertising from anyone prints a review of new cars. Are there sources of bias in this situation? There is no, but if you know there's no monetary gain from the person, so there does not appear any bias because it's not favorable to anybody who's writing this article. Number 6. Determine whether the results below appear to have statistical significance, and also determine whether the results have practical significance. So we look at statistical first and then practical. In the study of weight loss program, 7 subjects lost an average of 41 pounds. It is found that there is about a 35% chance of getting such results with a diet that has no effect. Okay, so it's 30% chance that they'll get this, that it won't have any effect if you go on a diet. So does the weight loss program have statistical significance? No, the program is not statistically significant because results are likely to occur by chance. Well, yeah, as I said, 7 subjects lost an average of 41 pounds. It is found that there's about a 35% chance of getting such results with a diet that has no effect. Okay, so the answer is going to be no with that information. Yes, the program's statistically significant because results are likely to occur by chance. That's backwards, so. No, the program is not statistically significant because results are unlikely to occur by chance. It just shows us that it does 35% chance it happens by chance. So no, it's just, yes, the program is statistically, no, it's not. Because there's a large enough chance if you do nothing, you'll still get the same results. So the only one that sounds logical is A. Does the weight loss program have a practical significance, have practical significance. No, the program is not practically significant because results are likely to occur even if the weight loss program has no effect. The results, even if it has no effect, that's just contradicting itself. So you're trying to lose weight. So if the weight loss program has no effect, then it's not a weight loss program. Yes, the program is practically significant because results are too unlikely to occur by chance. Well, unlikely is not practicality. So that's statistical. And remember, we talked about a 5% or 0.05 chance of occurring to be statistically significant. Yes, the program is practically significant because the amount of lost weight is large enough to be considered practically significant. 7 subjects lost 41 pounds. That does sound pretty significant. So far, this one's the best one. No, the program is not practically significant because the amount of weight loss is, it's not trivial. So it's got to be C. Refer to the table of body temperatures in degree Fahrenheit. Is there some meaningful way in which each body temperature recorded at 8 a.m. is matched to the 12 noon or 12 a.m. temperatures? Is there some meaningful way in which the body temperatures can be matched? Yes, each column at 8 o'clock and 12 o'clock temperatures is recorded from the same subject, so each pair is matched. That would definitely prove it. No, the 8 a.m. temperatures from one individual over 5 days and the 12 p.m. temperatures from another over 5 days. That's not a meaningful way. That wouldn't work. Yes, the 8 a.m. temperatures are all from one individual over 5 days and 12 from a different individual. No, if it's meaningful, to say these matching pairs, it's got to be from the same person. Yes, the 8 a.m. temperatures are from one individual, 5 days and 12 is the same individual. So each pair is matched. So it could be A or D. Each column at 8 a.m. and 12 a.m. temperatures is recorded from the same subject, so each pair is matched. The 8 a.m. temperatures are all from one individual over 5 days, and the 12 temperatures are from the same individuals on the same 5 days, so each pair is matched. They sound like exactly the same answer. Each column, each 8 a.m. temperature, all from the same individual. The only difference between A and D is this one says each column. So these go together, these go together. This doesn't say anything. It just says 8 o'clock and 12 o'clock. It's just each temperature of the same individual. So this one says that each column is what we're looking at. So yeah, I'll go with A. Number 9. Refer to the sample of body temperatures in degree Fahrenheit in the table below. Given these temperatures, what issue can be addressed by conducting a statistical analysis of the data? Given these temperatures, what issue can be addressed by conducting the statistical analysis? The data can be used to address the issue of whether there is a correlation between the average body temperature and a person's exposure to sunlight. Okay, yeah, okay, that's a far stretch. The data can be used to find the percentage of people whose body's temperature increases with illness. No, because everybody's body temperature increases with illness. That's not going to be good. The data can be used to address the issue of whether there is a correlation between body temperature. That seems directly what that one's doing. Because this one doesn't say anything about sunlight. So far, I'm eating with this one. The data can be used to address the issue of whether there's a difference between average, we didn't say average body temperature, this is the actual body temperature. So it's got to be C. A magazine ran a survey about a website for downloading music. Readers could register their responses on the magazine's website. Identify what's wrong. Choose the correct answer below. Well, first off, because the readers respond to the survey, they're self-selected. So if we say anything that's self-selected, then that's going to be it. The sample is a voluntary response. That's the problem. So there is a good chance results do not reflect the population. So far, it's a winner. The magazine has an interest in the survey results. So the source of the survey is questionable. No, because that's for the readers. They can't determine who answers it. It is likely that the survey used is loaded. It is likely that's loaded. It's either loaded or it's not loaded. The sample is a census. No, it's not. It's not. The census is the entire thing. So the answer is A. Remember, a census is 100% of everybody. The ad for a device used to discourage bike theft stated that this device reduces your odds of bike theft by 300%. What is wrong with this statement? Well, let's see. If it's 300%, so you decrease your odds by the first 100%. That means your bike can't get stolen. So anything after that is impossible. If you decrease your chance of 100%, then your bike's not going to get stolen. So the other that doesn't make sense there. The actual amount of the decrease in bike theft is less than 100%. Well, we can't. That's not what that's saying. The statement does not mention the initial amount of. Doesn't care. It just says it's going to decrease it. If bike thefts fell by 100%, it would be cut in. Oh, no, it would not be cut in half. It'd be all gone. If the device eliminated all bike thefts, it would reduce the odds of the bike theft by 100%. So the 300% is misleading. Yeah, that's it. All right, that's the first homework set. Good luck, everybody.